Welcome everyone to the Go Fly Master Lecture webinar series. We're happy you're here to join us this afternoon. Afternoon for us on the East Coast, another time where you may be. And without further ado, I'll pass it over to Gwen Leiter, CEO and founder of Go Fly, to introduce today's lecture.
Hello, everyone. We are so pleased that you are joining us today at the Go Fly Prize. Today, we have the opportunity to hear from Dr. Arvind Sinha. As you all know, apologies. As you all know, the Go Fly Prize is sponsored by Boeing as our grand sponsor. We also are partnering with a number of organizational partners, and today we are speaking from Florida at AIAA SciTech Conference, and so we are so pleased to be among a number of our wonderful organizational partners today. And most importantly for today, we are hearing from Dr. Arvind Sinha, who is Director of Engineering at the Helicopter Systems Division at the Australian Department of Defence. Dr. Sinha has a service record of over 42 years, which includes positions in the Defence Forces, industry, and academic institutions. He's held a wide variety of positions, including as specialist advisor, senior researcher, manager and director, and as a commanding officer of military units in operation. Dr. Sinha holds 2 undergraduate degrees, 3 postgraduate degrees in electronics engineering, aerospace technology, and business administration, as well as a PhD in aerospace engineering. So without further ado, we are so pleased to welcome today Dr. Arvind Sinha, and we cannot wait to hear about all he has to tell us in his master lecture. Thank you.
Thank you, Gwen. Ladies and gentlemen, good evening. For us, it's a morning in Australia, and I hope for the next 20-25 minutes, I can put across few points on the way forward in this challenge. And my real apology that I'm not on the video, but you have got my photograph there as to how smart I look. Anyway, I'm an old man, that's fine that I still continue to look smart. Okay, to start with, the key part which one has to be very conscious about, which I'm focusing on, is on design optimization. So let's look at the issues and challenges which are there in front of you in this design and manufacturing activity. The first slide, Paul. Okay. The first thing which one really, before starting any design activity, is very critical to see as to what designs have been there. For example, let's say in vertical lift, the ideas and concepts were always there ages ago regarding tilt wing and tilt rotors, but only thing that could not really succeed because technologies were not there. So in this case, the first thing one needs to know that we are wanting to design an individual flying device. It's very critical, an individual flying device. So you're not to be flown, but you have to fly it. There's a marked difference between the two. So there have been a lot of configurations which have come up, so one could really visit each of these configurations. Thereafter, one has to start thinking, because the key focus is innovative and revolutionary configuration. That's a very key part of this challenge. So one has to see whatever configuration you come out, how revolutionary it is. Then the 2 key parts which then comes up after that, what is the operational performance accepted from this flying device, and in what environment is going to fly. In this case, it is really challenging because we are going to talk of urban and rural areas. And the next point which comes in, which I said earlier, is where is the status of the technology in various things, whether it be systems, whether it be structures, or whatever we call that, or the components. So we are not going to really develop a technology in this challenge. We are going to use off-the-shelf technology and come out with a configuration. The last 2 points, which is also there, that it has to be safe. So which configuration, whatever you come out with after optimizing the configuration, which provides the, the higher degree of safety is critical. And the last point is the usage, how you're going to use it from the time you try to get it off, from the time you get it off the shed and be it assembling or whatever it is, fly off and then again store it. So those are the things which you need to. So let's get on with the next slide, please, on the existing configurations. My advice would be that straight away look at the merits and demerits of each of these configurations that are there or have been or still being tried out, and look at the merits and demerits from the perspective of the design that you are wanting to achieve. What are we wanting to achieve? Does any of this configuration have some merit which will assist you? So that is the first point to be seen. And then is what categorically it is mentioned, whatever flying device you come out with has to be safe, ultra compact, socially acceptable, and urban compatible. So one needs to look into what do you mean by ultra compact? What does that mean? Is it minimum number of modules, whether it be structures or the systems? What is socially acceptable? Noise is one of the points, but there are various other things like privacy, then what you call public confidence, safety. So you have to get on to each of the points and identify what is the socially acceptable air transport, in the domain of air transport, what is acceptable socially. So those are the points you come out and need to address that in whatever configuration you come out with. And last is the urban compatibility. Urban compatibility is all about trying to understand the layout, what is the standard layout of an urban area that is going to fly into that kind of environment. So that was about the existing configuration. You have to look at the existing configuration from these points. Next slide, please, on the innovative and revolutionary configuration. There's a very important specific thing which has been mentioned, extension of operator's body. You have to get the feel of flying, that is critical. That is the main point what we have to achieve through the design activity. The moment you say extension of operator's body, means it's going to be a device which is going to be mounted on the operator. It is going to be part of your body, which is very, very important. That is going to be part of your body. And the next is the open field, which is to do with the field of vision. So whatever configuration you come out with for whatever be the lifting devices or the power plant, they should not come within your field of vision so that you get the feel of the fly. And that's where the body mount, when I have to understand which part of the body it needs to be mounted so that the field of vision comes out. Though you may address the field of vision, that's fine. But to optimize that configuration, you have to understand the body mount analysis. Which are the places on the body which it can be mounted? Absolutely, which systems and components and where. And this is where I will guide you. I myself a combatant skydiver. The amount of loads which you get, combatant skydiver, and with full loads, you can imagine that's one area you can study. So that you already have a kind of knowledge base and experience base. When an equipment is mounted onto a soldier, or in my case, a Special Forces Commando, it's already calculated which part of the body will be able to take on the mount. So that's another area which one can study about to understand that whatever configuration comes out, which point of the body where the mounts can be placed. And those loads are very well calculated. In skydiving, there are very, very heavy loads which one cross. Once you have noted that, then whatever configuration you come out with, you have to understand the load analysis is a very critical part, very, very critical part, because here what we are aiming is a flying device where you get the feel of the fly. So whether it be the static loads, you have to understand in the configuration, the dynamic, the vibration loads, the maneuvering loads. So in this, a lot of maneuvering is going to happen because you're going to do urban flying. Urban flying, we are going to come to the operational environment. So that's what it is all about, the revolutionary configuration, how you're going to come out. The focus has to remain that it is an open field, extension of operator's body, which is critical, and the equipment is going to be part of you. That equipment is part of you like a combatant paratrooper. The equipment is just what we call so much skin to you that you feel it's your own extension of your body. Okay, that's about the innovative and revolutionary configuration. Coming to the next one, that is the operational performance. Here where it is slight transition, what we call it. In this case, it needs to be multi-mode. Multi-mode means two things. It's not only just from a vertical takeoff to a forward flight. It has to be in every direction because you're going to do urban flying. Urban flying is very clear. As earlier said, the layout of urban will require multi-modes. In various directional flights will be needed. The other part which has to be noted here, because it's urban, it will be low-level flying and nap of the earth, because you're going to address rural flying also. Nap of the earth, you'll have to read it. What's it all about, nap of the earth flying? So that is another your operational, what we call altitude, and the way you're going to fly is going to be nap of the earth and low level. The next part which comes in is the endurance, the power availability. Endurance comes with the power availability, but more the power you want to store, that has to be debated against the weight, because it has to be a compact, lightweight. Please remember, it's mounted on your body. The human body has to carry it. So we have to at each stage try to reduce the load. So whatever power plant which will provide the endurance, you have to look from a weight perspective. Stability and control, yes, this is where usage of your limbs and all that has to come out, whether it be landing, takeoff, en route obstacles and all. At the same time, manual and automated. Very critically given out if it can be unmanned, automated is also, or a manual override. One has to think what kind of system, stability and control system you like to have on board. At the same time, you have to focus that it does not add to extra weight. The more it's automated, the better. The last part which comes out in the operational performance, because you're going to go to low level and nap of the earth flying. So the audio signature is very important. Usually refer it as noise. I refer it as audio signatures are very critical. That has to be minimized. And most of the audio signature which comes out, it depends which configuration you're coming out, comes out from your rotors. It depends what configuration you are, the lifting device and the power plant. So one has to be very careful selecting these two in your configuration, how to minimize the audio signature. So that was the third point issue which I have mentioned. Now coming to the fourth point, next slide please. That is the technology availability. Technology availability is the critical part, off the shelf. Most of it will be off the shelf. So one has to set a configuration whereby you do not land up wanting to develop a technology. I think the game will be over the moment you think of developing a technology. Timelines are very less. So try and focus on understanding what technologies are available off the shelf, what has been used, and it's not only what is available, but how much has been tested, tried, and how well it has settled as a technology. That is the key part to see. So the technology, the first part is a structure, which is very critical, mounted, which I'm mentioning time and again, lightweight, because the human body carrying capacity is limited. You cannot cross that limit. And in this case, a lot of progress has been done in lightweight materials, and where the critical is that you're going for fiber, carbon or composites, wherever you can get in to get the weight as low as possible. But the additional load is certainly going to come from your propulsion system, because the electrical, or you can have with lower weight but get it charged en route. You could have some solar panels provided it's light and the technology is available. So mix in one night could be. I mean, I can't really say what solutions one can come out with. So some kind of mix of the power giving system could also come in. On the systems which are there, it's very good that the technology miniaturization has taken place. In this case, for example, the obstacle detection and avoidance, what we call at the see and avoid, is very, very important in this, because one is going to do urban flying. So one has to look which are the miniaturization systems which are available, so that it adds to the minimum weight. And the last part is the manufacturing and testing, as and when you go to the next stage, when you finally decide to develop the prototype. Somehow the simulations technology has advanced so much, one can simulate all this. So in parallel to the design, as you automate it, you'll have to really focus on the simulation part of it before you get on to the actual what we call flying. So that's about the technology availability. Coming to the operational environment, next slide. Crowded cities is very critical. So in a crowded city, what comes in is the man-made obstacles. One has to carefully analyze that, like I said earlier, whether it be power lines or the light pillars. At the same time, one has to understand the weather, the pattern of the wind and all in urban areas across buildings and all changes. A lot of studies happening as far as the what we call unmanned vehicles go, minis and micros, to use against various what we call adversaries who try to attempt to destroy public peace in urban areas, and we try to use these unmanned vehicles to trace the people. The key problem which they face is the aerodynamic side, the way the wind gust and all changes between buildings, between the streets. So one has to be also attend to this from a crowded city's perspective. What is the general layout of an urban environment? We'll have to map it out, literally map out that general area, how does it vary. Similarly, map out the wind condition, what it is, how the power lines are there. The next operational environment, which is rural areas where the natural obstacles come in. So that's another mapping you'll have to do. Generally, what a rural area looks like, natural mapping of it, whether it be trees, rivers, or what it is, whether it's going to fly in the terrain is going to fly, whether the rural is a mountain region or it's a jungle region or a desert region. So one has to look into all that as to what it is and map out these two operational environments very critically so that your flight profile of the device what you're making correctly matches that kind of an operational environment. The second last point, which I come the next slide, is the configuration safety. Safety is very critical here because you're more exposed any day because the equipment is mounted on your body. You're literally exposed. There's no cage around you as such. So the kind of emergencies which will come in for system or component failures, that is the redundancies which we'll try to bring about so that the individual can land safely, like you say for unmanned aircraft system. The days when the link is lost, then it's a pre-programmed whereby it can fly to a designated area and can land safely. So one can take ideas from that in this case of a system failure, that you can go out the urban area and land elsewhere safely. That is just an idea which I can give you as far as the emergencies happen. And crashworthiness is again when nothing can be done and you have to crash land. You have to crash land. There's no solution left. Then at least the structure's collapse design should be there. What you're designing, that it can collapse. At the same time, during the crash, there's no injury to the individual. One has to see if at all the device which you have designed and the crash has to happen, how we can avoid any injury, major injury. Minor injuries might happen. I can say that I have almost, I don't know how many jumps. The minor injuries are all there on your body, but there's no major impact. Rather, if at all the injury happens, there's a recovery to the injury. It does not cause your lifetime what you call damage. It's very critical. So one has to look into all these 2 points, that is the emergency and the crashworthiness. 2 separate things and keep away. At the same time, look into the weather, which I've said earlier, because in the streets, in the urban area, the wind direction just changes. You have noticed it yourself. And a good way to study is to study this unmanned system which they are wanting to use in urban areas against people who are public nuisances. So that's one area which I direct the designers to certainly have a look at it. The last part is the usage, which is one of the requirements which comes in the assembly and packing, because one never knows. It could be only one module or it could be modular, different modules what you put together. If you're looking at storage, then obviously you have to look at multi-modules where you can pack it up and store it. The volume and shape is very critical. As low as possible you can keep it. So maybe that you only come out a collapsible module, which is very easily to be assembled because not only ease of assembly, but the time required for assembling has to be very, very low. So how fast you can get it going. But these are the various points which I would rather advise you to look into it as you get into the design. As you start thinking about the design so that you can channelize your thinking and keep the focus. Once you keep this kind of focus to come out with a configuration and optimize it, then you certainly will be able to address the key part, which is safe, ultra compact, socially acceptable, and urban compatible. Last slide, that is the concluding remarks, ladies and gentlemen. Please make sure that it is a revolutionary design. Revolution, something new, something innovative. You're not to be flown, one is going to fly. Get the feel of the flight yourself with a total vision like a bird. Think of a bird. Birds do have flapping wings. In this case, you may decide which is whether you go to the flapping side or you go to the rotor side. One of the two sides has to come out. So one has to look into, as far as you can get whatever configuration you come out and you think it gives you the feel of a bird, then you have got the solution. You got the solution. Flight profile, the next point, very critical because of urban flying. The flight profile, which is how you map up the urban area. Human capacity, like I mentioned, because the equipment is going to be part of you, an extension of your body. It's going to be with you. You're going to walk with it. You're going to take off with it. You're going to land with it. So that's the human capacity one has to understand, which I have advised. Try and study combatant soldiers, and especially those airborne soldiers, as to how the capacity, how the human capacity is taken advantage of. Technology, our suggestion will be, as far as possible, no major technology innovation. That's not going to happen. Technology has to be most of it off the shelf. And the last point is the logistics, which I mentioned, that it was the usage, assembly, packing, storage, operational readiness. So, ladies and gentlemen, I think I've taken a perfect 23, almost half an hour getting to it. Last slide with my lovely photographs. You can't see me just before getting inside the aircraft to do my skydiving, which I'm still doing. So much thanks for listening. And as you go to the design, the last slide, safe flights, as and when you come up to that stage, and happy landings, because you're going to fly for the first time on this planet. Ladies and gentlemen, thank you very much. Okay, Paul and Gwen.
Yeah, thank you, Arvind. So a couple of questions coming in already for a question and answer session. So to start with, how about an easy one? What do you find inspiring about the Go Fly Prize?
Inspiring. The most inspiring part is for the first time humans will feel what's flying.
Okay.
Right?
Yeah, great.
Yeah.
Thanks.
See, most inspiring, it never happened on this planet. Never. People have tried, all has been happening. Myself as a skydiver, I felt what flight is before I opened my parachute, what is it like coming down, but it is not 100% flying because you're losing height continuously. And it's just, it's minor, it's just about 2-3% of flying feel you get in that. You're basically dropping. But in this case, you're controlling your flight. That's the biggest inspiring thing. And the day it happens, I myself would like to fly in that. So that's what is inspiring me.
Great.
Got it?
Yeah. And then a couple of questions about flying in sort of a more urban setting. What do you think is the most needed area of innovation for being able to fly a device like this in an urban setting?
Urban, no, can you get the question again?
Yeah, sure. So what do you think is really an important innovation for enabling a device like this to fly in an urban setting?
Yes, absolutely, which is there in your, you see the ground, it's basically a transportation system. The ground transportation system is now literally reaching its ultimatum. you get all the, what you call, traffic jams and all these things on ground. And it's high time to start using the airspace in the urban areas as another, what you call, mode of transportation, which is needed, where we use the unused airspace for flying. That's where the thing is, we can decrowd the ground movement. That's what I will always say that.
Yeah, great. So you mentioned how a device like this might sort of have a thrill or enjoyment factor, not having to follow roads, perhaps. Do you think that
yes,
absolutely like this might take sort of the scenic route versus the most direct route, just because it's such a joy?
Yes, there are two things. One is that whatever road system you got on ground, so similarly you'll have a road system in the air. As in more and start thinking coming. So it's, for example, let's say you got a road system above ground, you have got a underground also road system. So here you're going to have above ground. That's one. And secondly, the moment you get above ground, obviously the time requirement, because there's more of direct flights, because you're avoiding the obstacles, urban layout. So both ways it will be benefited. So you'll have 3 years of transportation in urban area. There is some place in urban area, you got your tunnels and all that is there. There are underground, under surface cities are also there, like in Montreal and all. So you got 3 levels. Now we're going to the 3rd tier, that is above ground, nap of earth, literally. A very low level. That's what it is. So we are trying to hit the 3rd tier of transportation, which has not been attempted at as yet. For a common man, for a common person.
Great.
Yeah.
Can you talk a little bit, again, just going back to this thought of flying sort of in an urban environment, can you talk a little bit about how a competitor might think about optimizing thrust while minimizing noise to create a machine that can fly but isn't, as you mentioned, a nuisance to people that are on the ground in an urban area?
Yes. Now, this is where it comes, the noise, the audio signal is very critical. So what technology you use, because the noise comes from where, as far as the machine goes. In this case, 2 critical areas where the noise comes. One is the power plant, the engine, on whatever kind of engine you use, the power source. And second are the lifting devices. These are the 2 which create the noise, which produce the noise, the audio signals. So that's what has to be addressed, which is the power plant which I take. For example, electrical power driven is certainly quieter than your engines or jet engines. That's the first thing. Secondly, again, it comes to the, let's say if it is a rotary wing, then what kind of blade design you come to reduce the noise. So these are, but certain level of noise shall certainly remain. That certainly shall remain. Is only trying to bring it to a level which is acceptable by the public. All right, you have got your car noises, you got your truck noises onto the roads when they are moving, but again, that is acceptable to a certain degree. So similarly, we'll have to look at how to reduce it so that is acceptable by the public. Have I been able to answer that?
Yeah, great, thank you.
Yeah.
So another question about the importance of simulation in the building process that competitors might be thinking about. Can you talk a little bit about simulation software and perhaps how important that might be in the development process?
Yes, yes. In today's, advancement, there was a time I learned my aerospace engineering on the drawing board, literally on the drawing board. There was nothing called as computers never existed, calculators never existed. So now you have an opportunity to simulate the complete design through your CAD, CAM, or whatever it is, computer-aided design, all that, and then simulate the urban environment. Your urban environment, that's what I was talking about, mapping a general, what does an urban city look like? You have to map it out exactly where it is. You have to map out the kind of wind condition that comes into that, the height of the buildings, and then simulate the flight in that condition to study the stability and control in that area. So you'll have to have a member, some kind of 2-3 members in a team who are IT experts, literally software engineers who are very good at that to develop such simulations so that all this is tried out, and that's where you'll get the confidence before you attempt the actual activity. This is a big what we call asset what we have got in hand in today's generation of engineers, what they have with them, which we never had that at all. So you simulate that. For example, let's say I was involved in one of the research activities of bird strikes to the aircraft. We simulated it totally. Same is like, for example, right now we're simulating as for a military aircraft goes, which I'm doing for one of the aircraft. In case a shot is fired at the aircraft, from what direction it comes in, which are the size of the shots. We simulated the complete structure of the aircraft. So if it hits at this point of the aircraft in this direction, at this speed, then how the structure damage is going to take place. So those are the things which needs to be simulated. In this case, the complete design and its operational performance need to be simulated before you get down to the actual activity of developing the prototypes. Got it, Paul?
Yeah, I do. Thanks.
Yeah, sure.
In follow up to your question about noise reduction, could you perhaps give an example from your experiences of having to make some trade-offs in design? For example, trading some performance for noise reduction or something to that effect?
Yes, absolutely. For example, let's say you're going for the rotors. So the blade tips, that one has to get to the basics of aerodynamics and all that, which is there in the textbooks. The blade tips and all, the way the blade tips are there, the way the angle of attack comes in, these are the places where the noise generation happens. Other than the transmission system, which is a rotor hub which is there, which is going to transmit the gearing system. So one has to study each of these basics as to where all in the blade design one can reduce the noise, the blades of the rotors, in case you're going for a rotor solution. I don't know what solution, lifting device solution one comes out with. This is in case one goes in for a rotor system as a lifting. So one has to really get into the blade design and the rotor mounting from where the noise is going to come. So trade-off happens is you can keep reducing the noise, but at the same time you'll have to look at the strength of the material, whether the lift goes down. So you have to trade off between the lift it can provide, the weight, and the noise. So there are various trading parameters which comes from which is in basic textbooks which one has to read through and come out which are the parameters against which it can be traded. At the end, the optimization, design optimization is that it should be able to lift that 200 pounds, I think I got some figure there, 200 pounds of weight plus the weight of the equipment which is coming out in the design. So it's going to be weight of the person plus that person. So you have to trade off within that so that you achieve that operational flight. Even if the noise might at times you'll have to trade off with the noise, I have to increase the noise so that to ensure that I get the required lift. So it depends how you do up the trade-off. The trade-off only happens once you start doing the design activity. So you have to look at which are the parameters against which I can trade off, but at the same time keep the focus that what device we are wanting to develop and what are the points which we have to address. In this case, it has to be safe, ultra compact, socially acceptable, and urban compatible. So you trade off between these. How much of urban compatibility you'll achieve, how much of compactness you'll achieve, and how much of social acceptance you'll achieve. So they all have to be traded off against each other. Got it, Paul?
Mm-hmm. Yeah, thank you.
Yeah.
For future personal air vehicle, like we're speaking of, what logistic issues do you think are going to be most important?
So what? Future?
What logistics issues do you think will be most important?
Yeah, logistics. Okay. First is here you have got a requirement which are given in the, I think the last slide, is storage, logistics, storage. Second is it depends what power plant you come out with. For example, if you come out with what you call electrical, obviously charging and all those things, how long, location where you'll have to charge it, that will come in. Third part is because it's a storage issue, assembly, packing, these are the logistic challenges how you're going to do. For example, my dream, yesterday I was just thinking about this when I was preparing my slides last night. And I said, yeah, if it does happen, so what is it? It's going to be flying wake parked inside your car park, inside the house. It's going to be there. So either it depends whether it's collapsible or it's a non-collapsible one. Depends how easily you can get it ready, switch on. and then you fix in the time. I say I want to go to this shopping center. It marks out the car park, or in this case it is a helipad or whatever you mark out. It flies there. So the logistics is about your parking, about your assembling, about your, basically the storage and the operation, how ready you can get it moving. Like today's technology, you just get in the car and just press the button and it's all ready to go. Minimum maintenance, minimum repairs needed. These are the things one has to look into when it comes to logistics, to minimize the logistics. Reducing logistics is going to remain. You can't do away with it. It's how well you can minimize it. But it shouldn't happen in the sake of minimizing the logistics. You don't achieve the operational performance. That is very critical. What is your tutorial? Again, it's a trading off between logistic requirement and the operational requirement. Got it, Paul?
Yes, thanks. A couple of people have keyed into your comment about a device perhaps being body mounted. Just wanted to point out that that's not technically in the rules. It would be possible for somebody to create a device that you sit upon or get into, perhaps. Do you think, could you sort of lay out maybe some pros and cons about what somebody would be thinking about as they make the decision to create a device that you wear versus get into?
Yeah, now you see, this is where the point is. What I've been mentioning the body mounted is, we have very clear the feeling of flight, the vision. These are two things which is the biggest challenge in this Go Fly, is to get the vision completely, feeling of a bird of flying. You have not to be really seated, literally seated in the vehicle moving because you're being flown. But here you have to fly it literally and get the feel of the fly is a totally different thing. Sitting in an aircraft, including today, we have these certain devices, existing configurations are there. Do you get the feel of the flight? That's one. In this case, it is urban. The game is socially acceptable. So somehow to get the feel of the fly, my gut feeling is that it has to be body mounted. Then you'll get it's an extension. That's a requirement which is given, which very categorically says that it is an extension of operator's body. That's the requirement which has been laid down into the design, into this challenge design activity. Extension of the body. Extension of the body means it has to be body mounted. So that's where I keep mentioning that one has to keep working on the mind. How do we go about having it body mounted? Got it, Paul?
So Arvind, I just want to mention for those listening that it's not actually a requirement that the Go Fly device actually be body mounted. You're right that the vision statement is there, but also the rules state a number of different scoring parameters that will be followed, and that's requirements.
Absolutely, the last one which is there in the scoring parameters. Yeah. So that's one of the ideas which are placed across, because body mounted is going to get you the totally 100% feel of flight. Though it might be a long way, we might not achieve in this, but that's one thing to think of as to how much can be body mounted or not body mounted. To what degree you can get it to body mounted. Got it?
Yeah, great. Thanks, Arvind.
Yeah. To what degree you can, if you want, because the moment a person would have heard that, you think, oh, 100%, need not be 100% body mounted.
So just one final question before we wrap up here, Arvind.
Yeah.
So sort of in conclusion, what is your biggest piece of advice to competitors? What's the thing that they should, what's your piece of advice to competitors for competing?
Yeah, my biggest advice is just to keep focused what we are wanting to achieve out of this challenge, which is very categorically laid down in the beginning itself. And that is about, it has to fly in crowded cities, rural areas, it has to be lightweight, maneuverable enough. So that should be always your focus out of this. It depends to what degree you can achieve each of this and how you can optimize each of this. All the items which are there in the challenging language which is given. So that is my piece of advice to everyone, to keep that focus in you. Keep that focus. It depends how much you achieve. That's besides. To what degree you can address it. Otherwise, you'll wave away from it, because there are already individual, flying devices. It does exist. Not that it does not exist. People have done it. But here is a challenge, the feel of the flight, which has to remain there. Got it, Paul?
Yeah, thank you very much, Arvind. We very much appreciate your participation today.
Yeah.
Yeah, so just a couple of words here from myself and Gwen before we wrap up.
Yeah,
thank you, Arvind.
thanks.
Yep. So just wanted to remind everybody who's listening that the official rules are at the GoFly website. That those are the rules that will be used for judging and scoring, and you should keep those in mind as you're putting together your submissions. So just make sure to make a close read through there, as those are the official rules. So I'm going to go ahead and pass it back over to Gwen to say a couple parting words to us before we end.
Hello, everyone, and thank you very much to Dr. Sinha for giving us an illuminating master lecture. As you all know, what the device looks like or how it works is up to all of you innovators. There is no one right design or one way of working. And so it was incredibly interesting to listen to Dr. Sinha and to listen to him speak about a number of different types of configurations and issues for each of them. We look forward to seeing your innovation. As you all know, the phase 1 submission documents are now online, and submissions can start now. They are due April 18th, so you still have some time. We welcome all of your innovations, and we welcome all of your different designs, whether you are strapping something on or standing on it or getting into it or doing whatever and however you devise your device. We welcome the opportunity to review and to learn from you all, and we appreciate very much the lecture today by our master, Dr. Arvind Sinha. So thank you so much. And if any of you happen to be at AIAA SciTech, the GoFly team is here in Florida at the conference, and we look forward to speaking with you personally if you are here. Wishing you all the best. Thank you.